I'm going to do an overview of sort of how Globus provides support for large data transfers and collaborative sharing of data. I have a few slides, but I'm going to do a lot more hands-on. I'm just going to show you how the system works and go from there. Feel free to stop me for questions through the talk. So Globus is a project that's been around for more than 15 years now, and we focus on distributed systems in general. And this talk specifically is going to focus about Globus's features for big data transfers. You see big is in parentheses there. It's what you define as big. So large data transfers, sharing of data with collaborators, and then publication and discovery. So if you're looking to associate metadata with it, make it available with identifiers and so on, how do you do that? And that's sort of what Globus provides. It provides a software infrastructure that you can leverage to do that. And a very key point in all of this is that it's off your own storage system. And the reason this is key is whatever institutional storage that you have, that you use, or whatever allocation that you have, Globus just leverages that and layers on top of it. So this is not you moving the data to a separate storage or to a cloud storage. This is taking data sitting in your various storage systems, and how do you move them around? How do you share them with collaborators? Everything from the existing storage, right? So I'm going to talk roughly about a few use cases. So what are the problems we're trying to solve? And then I'll go through then the specifics of how does transfer work, how does sharing work, and then publication work. And then finish off with some examples of how people are using Globus today. So the first use case is, like Rob said, okay, I have large amounts of data that I need to move around, right? So you have resource clusters, you have lab department servers, you have various machines, potentially even the cloud. A lot of people are using cloud for backup these days, even from campuses. So how do I replicate the data or move subsets of my data around, but do it reliably and do it such that it happens as quickly as the pipe would allow, right? Between large research systems, you have really good connectivity. So how can you do it such that you can seamlessly do it, but also do it very quickly, right? And the second one is a sort of different take on the same problem. If you're sort of getting experimental data from an instrument, be it large systems like the light sources that are around, or from next-gen sequencers, or even the light sheet microscope here. It's a core facility in University of Chicago. It's a small machine that spits out a lot of data. So if you have that sort of data that you're collecting, how do you reliably move it for processing? Typically, those caches are very small, so you need to be able to automate the process of moving the data out, both reliably and safely, right, securely. So that's the use case here. And then the third one here is wanting to securely share data. So most often you see a lot of the scientific projects, most often, almost always, involve multiple institutions. So you have collaborations, you have grants across institutions, and you're looking to share data with your peers who are sitting on different security domains, right? So you're working in one campus, you want to share it with somebody in a different campus, and so on. So how do you securely share the data with them, be able to do it on subsets of data, not have to move large data around, so you're not sort of making a second copy of the data to share it with them, and not worry about giving them all accounts in all these machines, right? Just for the purpose of accessing data. So how do we make collaborative science possible here? How do you make it easy to share the data? So that's our third use case. And then the fourth one is sort of around the backup and archive. So this speaks a little bit to the hierarchical storage management. So a lot of times you have your Scratch, your project space, and then you end up having a tape. And you're often required to move data across these. But ideally, you want them sort of policy-driven, automated to whatever extent possible, but seamlessly do this and find data, right? So there are examples of tape in public cloud here, which we are seeing more and more people using things like S3 and Google Drive to actually back up data. And then the last one is, okay, great. You have lots of files. You've finally processed them. You moved them around. It's sitting where it is. Now you want to be able to publish them, right? So different people have different meanings for the word publish, but what I mean here is being able to associate some metadata, being able to provide an identifier so that you can tell somebody, okay, here is a digital object identifier or a handle, and if you go there, you can find the metadata and the data associated with it, right? So being able to reliably publish your data set to make it available to users, be it sort of restricted publishing, sort of publishing only within your collaboration, or the publishing where you're making it available to the world, right? So how do you do this? Not just for the papers, but the actual data sets associated with the science, be it small or big data sets. So this is sort of the range of use cases that Globus as a service is looking to address. And mostly today, I'm going to focus, and the hands-on exercise is going to focus on the transfer and the sharing aspects of it. And then the publication, I'll talk over it, but I'm not going to do a demo today. So let's talk about the first thing, reliably transfer data between machines, right? So Globus in center here is the service. It's a hosted service that operates on the cloud. A user initiates a transfer request to Globus. So the user tells Globus, I would like to move data from, let's say in your example, ALCF to NERSC, right? I have data sitting on a folder in ALCF. I want to move it to NERSC. Or even within ALCF, being able to move it. They submit the transfer request. And at that point, it's a fire and forget request. The user walks away. And Globus manages the movement of the data, right? So what does that mean? So it initiates the transfer. It manages the security credentials that are needed for you to transfer. It does automatic fault recovery. So if you have any issues with your transfer, blips in network or what have you, it pauses the transfer and picks up. It also does automatic tuning. So are you moving lots of small files? Are you moving a few big files? It's up to the client to be able to tune the parameters on the network so that you move it as quickly as possible, right? Globus automatically detects those things and applies heuristics and moves the data, leveraging the bandwidth there. So from the user perspective, you're pretty much sort of, in place of running a command line client or in place of running a client that you're managing, you are asking Globus to sort of move your data, and you're able to walk away, and it does the data transfer. We can also support S3 endpoints, like I said. So I gave you examples of file systems, like shared file systems on various centers. But if you're looking to move to an object store like S3, you could do the same thing. You could come to Globus and say, I want to back up my data or move this subset of data, and we'd be able to move the data there. So let's make this concrete, right? So here is one interface to Globus. So it's a service. So there's a programmatic interface. For you guys who like to write code, you might want to do this using program. But about 95% of our user base uses the web page, right? So you log into Globus. It's very easy to create an account. I have one. I'm not going to. You just establish a username, password there. Then you go to the start transfer page. So this should look like any other GUI transfer tool that you've looked at. And here's where you bring up the system from which you want to transfer, right? So for example, you all have ALCF accounts. So if I type in ALCF pound, you see it gives you the names of systems that is Globus enabled for transfer, right? So you have their HPSS system, Mira, and Vesta, right? So you can pick the system from which you want to transfer. This name is a logical name for the server running on ALCF. So some admin has set up a server to move data on ALCF, and he has given it a logical name. And we call that logical name endpoints, right? So in Globus documentation, if you ever see endpoints, they're just logical names to storage systems that have been enabled for Globus access. So ALCF, NERSC, OLCF, many of the national labs have this. So if you search for them, if you just type in OLCF pound, it'll autocomplete. You'll see a whole bunch. So if I pick the endpoint, the first thing it's going to say is that you need to authenticate, right? So just because it's enabled by Globus doesn't change how you access the data. So I don't have an ALCF account, but I'll just show you what happens because you guys can try this. The minute I hit continue here, it's going to take me to ALCF's login page, right? Which probably you guys have seen. So you provide your username, PIN plus password, the same thing. Now these passwords don't flow through Globus. It's being authenticated at ALCF, and Globus is just getting your identity, right? So given I don't have an ALCF account, I'll pick something that I have access to. So let's take University of Chicago has a cluster called Midway, which is our research computing cluster, right? Same thing, I go to RCC Midway. First thing it says is authenticate to your endpoint. As soon as I do that, it's going to take me to the University of Chicago's login page. So this is the login page I use for everything at the university. It's a single sign-on credential, right? So I authenticate with that. and then it's going to take me back to Globus, and it's just going to drop me in my file system. So these are the files that I have, right? And if you guys logged into ALSEF, you'll just see the files that are sitting on Vesta or Mira or wherever you logged in. Then this is a standard browse. I can browse up and down. I can only see what I can do. And it also has some additional functions to rename or delete, simple file system operations that you can do, you can manage from here. So I'll pick another endpoint. I was going to use NERSC, but Oakland has an electric problem today, so I can't use NERSC. I'll use a simple test endpoint that everybody has access to. It's called go_ep1, right? So you pick your other machine, wherever you're looking to move data. So you can pick a folder or a file and then say, I would like for this to be transferred. So at this point, I've requested Globus to move the data from my University of Chicago cluster to another endpoint that's running somewhere else. The data doesn't flow through us. It's going to use the network bandwidth between UChicago and the other endpoint, right? So if you're moving from NERSC to LCF, it's going to use that network. It doesn't flow through us. But at this point, I could walk away. It's going to do all the transfers. It's going to do checksums automatically at the end. If any of the checksum fails, it'll automatically retransmit the data for you. And restarts, pauses, all that is sort of taken care of, right? There are some additional options you can do on your transfer settings. So like I said, it automatically just checksum verification. It's a checkbox. I don't know why anybody would turn it off. It's never recommended. So we automatically do it, and it'll retransmit the data. You could also do synchronization, anything that you can do with, let's say, a tool like rsync, right? So I can pick two folders, and then I can say move only files that are different. And if you've used rsync, the exact same operations as rsync, right? If checksum is different, or if file doesn't exist in a destination, file size is different, or if the mod time is different. So you can also submit a request to say, sync these two folders, and the same thing is going to happen. It's going to move the delta out. There is an option to encrypt transfer. We do not do that by default because encryption has a huge performance penalty. Well, huge is an exaggeration. It does have a performance penalty. But if you have sensitive data, I know I work with some groups who work in life sciences, and they do have sensitive data that they like to encrypt. You could use that option, and all the data that's flowing on the wire is encrypted. So it's both integrity and privacy protected. So that's sort of a very quick overview of what transfer can do. And everything I said, you could do it using other interfaces, and I'll show that also. So the second thing I want to talk about was moving to your laptops, right? So I talk about these endpoints as logical storage locations enabled for use with Globus. Often, these are run as servers by your institution. So whatever resource that you're using, the resource administrator would have set it up, and he would have given it a logical name. All you need to know is the logical name. And behind that, they might have multiple servers for performance purposes. They may bring down a server. They may do maintenance. From a user perspective, all you remember is that logical name and go from there, right? But what if you want to move data to your laptop or a desktop or a machine that you own, right? For that, we have something called Globus Connect Personal, which basically is a way for you to set up an endpoint on your own personal machine. It doesn't require any admin privileges to install. So if I click on that, it's going to ask me for an endpoint name. I give it, what do I want to call this one, a logical name? I probably have a laptop, so let's try, okay. So once I give it a name, I generate a setup key. This is the one thing you have to do. It's like installing a Dropbox agent or a Google Drive agent, right? It's a one-time setup, and then it auto-updates. So you pick the binary that works for your platform. And then once I start that, once I install that, it's going to ask me for the setup key. So you want to copy that to your clipboard. So I installed this once. It runs in the background, and it pretty much does auto update of itself. So you do it once, and it links it to your account. And this endpoint that I'm installing is not a public endpoint. Oops, I have an older install of this. It's not a public endpoint, so it is going to Sorry, I'm going to clean this up a second. I have an older install. Okay, let's try this. So unlike the ALCF one, the NERSC one that I talked about, an admin has set it up for all of you to use, anybody who can authenticate to use it. But this is a personal one. So this is not something you can even find, and you will not be able to use it in your, you will not be able to find it or be able to access it, right? It's just an install for me to use. So it just sits on your machine. Note, I didn't need any of my admin passwords, so you don't need root to install this. You can install it on any machine that you have access. And it also does not require inbound firewall. So you can set it up on a machine without asking your administrator to open up firewalls, right? When I first clicked on this, and I gave it a name, whatever I want to call it, you know, my MacBook or whatever I want to call it, and then you hit generate setup key, and you get that, right? So that's how we are tying the particular install on this machine to my account. I canceled the MacBook one, I think. So let's try laptop 20. OK, there it is, right? So that was my full install. So this is just my machine, that's all, right? So you're seeing, again, now you can move data, synchronize between these two. And the cool thing is it'll also pause and pick up. So in a setting like this, if I start a transfer now and my talk is finished, I close my laptop, I go back and open it up, it's going to pick up where it left off, right? So it's going to worry about the end-to-end download. I often get asked on desktops, how is the performance, right? The performance is going to be as good as the wireless in this room, right? So it's not like it's going to do, it's going to be rate limited by the pipe that's connecting your machine. But we can do the best with that pipe, right? Because we are doing auto tuning, and and the best part is you don't have to babysit this. You can start it and you can walk away. Yes.
Is it peer-to-peer or is it via Globus?
But it's using a protocol called grid FTP. It's basically high performance FTP. So if I do a transfer here from my laptop, from let's say UCRCC to my laptop, let's move it to my folders. It's basically going to move directly from University of Chicago to my laptop. That's it. And it's using an FTP-like protocol, but it's a high-performance FTP protocol.
So if you have a power cut also, it just keeps going?
I'm sorry?
If the laptop dies in the meantime?
It's going to pause, right? So Globus has state. So what the role Globus is playing in this is it's a stateful client that's sitting in the cloud, right? So we get markers saying, OK, so many bits have been moved all the time, so we're monitoring the transfer. So we know how much was moved. If your laptop dies, the next time you bring it back up, we pick up where we left off, right? Yes, Phil?
When you do a transfer, how do you find out that it's done once you started one?
Right. Very good question. Thank you. So there is a page which tells you what is happening. You could go look at transfers. But also, you will get an email. You will be notified via email saying that the transfer is completed. There are also a few other reasons why you might get an email. If there are errors that we know we can't recover from. If you have a quota error, right? We really can't do anything. We could keep trying and make your administrator very angry that Globus is trying to hit your machines, right? So there are things like that we can't recover from. We'll send mail. But again, the transfer is paused. So in case you somehow manage to get more space by deleting something or convincing someone to increase your quota, transfer will finish. So we just pause the transfer, right? Then there is another important reason you will get an email. So if you notice, when I first went to ALCF, it asked me to log in, right? When you guys log into ALCF, we don't see your username password, but ALCF gives us a short-term token, if you will, that says, OK, Globus can access the file system and move the data for a period of time. Each resource owner, each storage provider determines how long that is valid, right? So for example, NERSC, they give it to us for 11 days. So if you log into NERSC once, for 11 days, we don't have to have you log in again. We can keep moving data, right? ALCF, on the other hand, for Mira and Vesta, gives it to us for 12 hours. So just in case your transfer lasts more than 12 hours, and plenty of transfers do, depending on how much data you're moving, then when we hit that 12-hour boundary, we will not be able to continue the transfer anymore, because ALCF will reject our login, at which point we will pause the transfer, and you will get an email saying you need to authenticate again, and you'll get a link. You click on the link. It'll take you back to the ALCF page. You authenticate, the transfer will pick up where you left off, right? So again, the whole idea is to provide the management layer for the transfers and just layer on top of the security that the institution has, right? And it's going to be a wide range. Many of them give us 11 days. Some have policies of 3 days. ALCF is 12 hours. OLCF is 4 days, I think, so many number of hours. So depending on that, and if your transfer does cross the boundary, we'll pause it, and then you will get an email about that. So on the Globus Connect transfer, you can see mine is spinning because data is moving. I'm sure it's moving very slow. But I could also pause it if you don't want your network to be used. It's like an agent, any other. I have a Dropbox drive. I have so many agents. It's just going to sit in the background and operate that way. Okay, one last thing before I go back to my slides. I'm sure this audience loves it. We have a command line. So it's a hosted command, a little different. So the way this, we recognize most people want a script. A lot of people like using command lines. Not many people like the web app. Okay. So in such cases, we have this idea of a hosted shell. So what you do is you go to Globus, and under your name, there's a manage identity page. You basically link your SSH public key here, right? You tell us, so there's a Globus account that's sitting, and you're saying, oh, when I log in with this SSH public key to Globus, it's linked to this account so that we can link those identities. Once you do that, so and very specifically, you say add a linked identity, my SSH public key, and then you just drop in your public key from wherever you're going to authenticate, right? I've done that before. So then I say SSH, my Globus username, at cli.globusonline.org. And here, this is a restricted shell. And if you do man, you will see that you can do everything that I did from the web app here, right? There's a command called transfer. There's a command called ls. There's a command, the transfer command takes synchronization parameters. You can check status of your transfers. You can pretty much do everything that you can do in the web app from here. So for example, so I just logged into my University of Chicago, right? So I could do ls ucrcc pound midway. That was the name of the endpoint at University of Chicago, :/, and it's pretty much just going to give me a listing of the file system, right? There. Then there's a transfer command that I can do the same thing. So I can say transfer ucrcc pound midway, :/. Let's give it a path. And I can give it a remote endpoint. So I could do my laptop. It's paused now, but whatever, right? So you run this, and it's pretty much doing this. The key thing here is that we have sort of looked at it also from some light scripting perspective. So you should be able to script all of this, by just add sshcli@globusonline.org to your command, script it, get status of transfers. So there's a command called status. You run that. It's going to give you these are transfers that are actually running. On the status command, you can pick give me only these fields, grep for success on it, and so on. So everything you do from a web app, you should be able to automate using the CLI and just use that. Yes?
How do you handle authentication in the scripted environment?
That is a challenge. I was going to come to that one. So there are 2 exceptions. Well, actually, there's one exception of where you will be forced to go to a browser, right? There are 2. I'm afraid NERSC is not. So there are 2 kinds of endpoints that we work with. Folks like ALCF, where they require you to go to that web form to provide username password. They do not want it to flow through us, in which case you have to activate your endpoint on a browser before you start your script, right? And then there are others like NERSC, where they are OK with their passwords flowing through us, in which case you can script completely for NERSC, right? You can pass the username password. Globus doesn't cache it, but hands it to NERSC and gets a credential. But increasingly, sites are moving away to where you will need a browser to do it. So that's one exception where you'd have to go to a browser and activate, right? So if I tried, let's say, Exceed is another set of sites. Let's say Gordon. It's going to print the URL. So Exceed is another site like ALCF that doesn't allow me to provide the username password. If you notice, the error message says, please go here and provide your username password, right? Once I do that, the LS will work, but we can't do it from a command line. That is a challenge for some of the scripting use cases. Then the next one, if you remember my use cases slide, I talked about wanting to share data, right? So you're working with a set of collaborators. Your data is sitting on a machine. they all don't have accounts on it, but you want to just share data with them. So what we do here is you'd be able to go to Globus and pick a folder after you've authenticated, something that you have access to. You pick a folder and say, I want to share this folder with another user, right? And you can share via email address or via a Globus account or even to a group. So when you do that, you set permissions, and Globus manages the permissions. It says, OK, Rachana has allowed, let's say, Rob to read from this folder, and we manage those permissions. Then the other user, so now Rob can log into Globus and access that folder, and we enforce such that he can't touch anything else in my file system. He just has access to that folder, and he can download data from it. Right? So it has somewhat parallels to Dropbox, where you're able to just do subset of data, share it with somebody else. The key difference is that I did not take my data and put it in the cloud. Right? I shared it off my existing file system, which actually uniquely meets a lot of the research data requirements. It could be big. It could be something that you are not allowed to put in the cloud. So there are a lot of reasons why a solution where you have to replicate doesn't work for users. So something like this works off your storage system, and you're able to share a subset of data. You could also share read-write. So if I want him to put data back in there, I could also set permissions for him to write into that folder. Right? So how does that work? So I'll go back to my University of Chicago page. So let's say I pick the folder here. CSSEF is a climate project that I work with. And then I can say, I would like to share this folder. First thing it asks for is a logical name, right? I'm going to share that folder with somebody, so you can give it another, it's just a virtual name, another pointer to that folder. So I'll say, for demo or something like that. Now, I've created, if you will, another endpoint called my username pound for demo, and now I can manage permissions for this endpoint. So I can say add permissions, and I can start figure whether I want read or write permissions, and I can share via email. So I'll show the email first. So you provide the user's email address here. I'll share to myself here. And if I hit add, what is going to happen is an email is going to be sent to the user saying that Rachana has shared this folder with you, right? And then I'll do a few other permissions and show you what the folder looks like. You can search for the user in the Globus database, and you can find the user. So for example, I can search for Foster, find the Foster, you see their account name, and I can say I want to give him read permissions on it. Or you can also set up a group of users. You can create groups and users and set permissions. So what does this do? Now the user who received permission to this, when they go to the folder for the endpoint I set up, all they see is the data sitting inside that folder, right? So I shared the folder CSSEF with them, but that user has invitation only to that folder, and they can see only the data within there, right? If you notice, they can't browse up, they can't touch anything else in my file system. So effectively, I've created, if you will, one folder, sort of sandboxed, and permissions on top of it, and given somebody access to it. If I've given read access, they can download from here. They can transfer data out of here. If I've given read-write access, then they can write into it, right? But remember, it's all pointing to the same location on the machine. So if you give me read-write access, I can overwrite something in the folder, right? It's just the same location. It's just managing permissions on top of it. Right? So that's sort of how sharing works. You could also share with groups of people. We see this in some of the collaborations where they have a group of people they want to give read access to. A group gets read-write in different folders. So you can go create a group. And actually, one of your hands-on exercise has you joining a group here. So Globus has a full-fledged group management system. So I can go create a new group. And then in place of setting permissions for just a user, if you go to the if you go here, in place of setting permissions just for a user, I can say set permissions for a group, right? So we have a group called Globus team. I can search for a group here and say, I want to give permissions to everybody in the Globus team. Again, read-write permissions. And then lastly, you could also share with all users. So you could say this data is public. I want to make it available to all users. We do have some groups who use this as the way they distribute data, so data that they need to make available to the public. But the only thing that I should note here is that when they come to access it, they will need to log in with a Globus account. So there are pros and cons to it, which means you get metrics on how many people have downloaded the data and so on, but it's not anonymous download. So they will need, when they come into access, they'll have to get an access to it. No, they'll have to get a Globus account. Any questions on sharing? Yes.
So how can we see like what has been shared like to everybody? That's your last point.
Right, so this is sort of the, if you go to the page called Manage Endpoints, there's a link there. If you go here, you can say, what are all things that are shared with me? These are things that are shared with me. These are all things I shared. So there's category. Similarly, on the CLI, you can do a search saying, give me all the endpoints that have been shared with me, sort of thing. Yeah, so it's a discovery question. Often when people, if somebody shares specifically to you, either as a user or through email, then you will get an email. Even if they search for you in the database and find you, you will still get an email saying this has been shared with you. So you can go look at that. So the last piece I talked about was Globus data publication, right? So very similar to the other services, the idea here is for Globus to provide a service where you can come in and associate, can create collections, associate metadata with your data set, get identifiers for it, and then make the data set available to either a restricted collection is only to some people or to a larger audience, right? So typically, an admin creates a collection and sets policies on who's allowed to submit to it, when data set is put in the collection, who has access to it, and so on. A researcher then uses Globus to provide the metadata, points to where the data is sitting, assembles the data set, if you will. If there's data sitting in multiple locations, you use the Globus transfer to sort of pick where the data is. Then Globus sort of collates all of that, creates the submission piece, right? The data set associated metadata, everything that was submitted. And there is a curation aspect. So there might be a curator who comes in and reviews to see whether the data set looks OK. It could be a manual curation. We have collections where people just review it manually. There could be automated curation where you run it through tools, like is this NetCDF, CF compliant, and so on. And then when the curator says OK, then it gets published. And when it gets published, it gets an identifier. So the data set gets an identifier like a DOI or a handle, and then gets indexed for search and discovery. So somebody can come to Globus and search for characteristics and then discover the data sets associated with that, right? So I'm not going to do a demo in the interest of time. There's a lot of, so I'll just do a quick walkthrough here. So this is the Globus publication interface. So you have collections. For example, here we take every institution as a collection here. So Chicago has its own set of collections. Argonne has its own. So a scientist chooses the collection to which he wants to publish data, and then he describes the submission. So there are standard metadata forms. We have templates that you can use, or you could do custom metadata yourself. Once that is done, the scientist then assembles the data, right? So for example, if the data is sitting on your storage cluster, an Isilon machine there, or your laptop, you have some graphs, whatever you have, you sort of say, these are the files associated with this data set. And that gets moved to the final location from which it's going to get published or served. Once that is done, there's an optional curation step, at which point the curator has access both to the metadata and to the data. They can review it, and then they publish it. Once they publish it, it becomes available as a part of the search, right? So the users can come in and search either using the metadata or using, if you have a digital object identifier, if you know the DOI, then you can plug that in and have access to the metadata and the data. So the publication itself is sort of an important side because people take away different meanings of the word publication. So when somebody's publishing data, usually there are a few attributes to that, right? So you want to get an identifier, you want to have a description to the data, you want to have some sort of curation, you want to determine what access you want to provide to it, and then finally preservation. So when you publish, how long is the data available? And each of these has we do the slightest scale of, depending on what sort of publication you want to do, there are different things, right? So for example, as a part of a project where you're just sharing data within the collaboration, you might simply want a handle or even a URL as an identifier because it's not going to get preserved for a long time. You may have your own custom metadata that you've agreed within the project. Maybe the curation is just hand validated and it's available only to your collaborators, right? So you can pick sort of what attributes you want for your collection, and that determines which aspect of it falls. Whereas on the other end of the spectrum, let's say you're publishing it through your institution, your library is maintaining it, then they pretty much probably looking for a DOI, a very standard metadata, machine-validated curation, so that there is preservation involved and so on. So the publication product is meant to support these various use cases. The lightweight, I'm a researcher, I'm going to keep this data for 5 to 6 years. Within my collaboration, here's what we agreed on. 2, I'm sort of making this publicly available as a part of, it's linked to my paper, and I want to publish the data set and what aspects of it you need, right? So the product sort of supports a wide range of use cases there. So those are sort of 3 things. I talked about interfaces. We have the browser through which you come in. So I come in through, browser was one interface I talked about, and then the CLI was the other interface talked about, right? But we also have a service. So we have a full-fledged API that you can use to programmatically do this, right? So even our web browser, the web app client that you saw, pretty much is a REST client. It uses our service for everything that it does. And it's sort of also built up. So the identity management, the group is a lower piece. Then we have API for file transfer and sharing. And then we have APIs for an interface for publication. So if you have portals, or if you have third-party applications, whether they are thick clients or otherwise, that want to use some aspects of Globus, then you should, without having to use our whole web app, you can use the API and just use some aspects of Globus, right? So that's sort of what the interface there is. It's a public API through which you can access it. And there are quite a few people who have done that. I've put in 3 examples here. I'll pick the second one, the Research Data Archive out of NCAR. These guys have so many petabytes of climate data that they actually serve, right? So they have their own portal. People come in, search for the data, and then they ask either for a subset of the data to be given to them, or they sometimes ask for some derivative analysis to happen, and then for the data to be provided, right? So RDA has all this logic of how somebody comes and custom search, how do I do this data cart model, and then they were providing HTTP downloads. So then you would say, okay, download, and then there's a link, you do a wget or through your browser. And they were starting to see scale problems, right? As the data sets were growing bigger, users were seeing huge issues with how much they were able to download or how performant it was. So what RDA has done is they've included Globus transfer as an option for download. So the RDA user does not come to globus.org, like what I showed you. They still go to their portal, and then they search for the data. They still put in their data card. And from the data card, there's a link that says download using Globus, right? Behind the scenes, RDA is using our API to set up the permissions. So they do the derivative analysis. They put it in a directory, set up permissions like how I showed you, read access for a particular user, and then have the user sort of use the Globus interface to download it, right? So it's a way for you to say, I have a custom user experience or a custom requirement that I've already built around, but I just want to outsource the transfer piece, or I just want to outsource the sharing aspect of it. And they've done this using, actually the RDA integration is a mix of CLI and the API. So they also use the CLI commands behind the scenes in their portal. K-Base there uses actually Globus's groups and account management. So anybody who logs into K-Base uses Globus for signing up, managing their profile, and so on. So it's a different piece of Globus that gets used. And then this one is Earth System Grid, another climate project that distributes CMIP data. And very similar thing. They have their own portal. They have petabytes of distributed archive. But they're just outsourcing the transfer piece. If a user comes and asks to move data, they have an option by which you say move using Globus, and just that piece is used. And this was done using our API. So it uses a Globus API to do the transfer. So it's not sort of, it's the piece where you don't necessarily need to do ad hoc transfers, but you want to integrate with your ecosystem. Really quick on the slide. So it's the service has been in production for over 5 years now. So we have transferred, we actually crossed 100 petabytes, I think, last month. We're about 107 now. There's a counter on our webpage. Lots of different files, so each transfer can have any number of files. There are no limits on how many files that you can transfer, so many people do directories that have millions of files. Lots of registered users, but more interestingly, there are about 300 active users, sort of people who come in and are daily doing transfers through this, right? So what might be of interest in all of this for you guys is the fact that there are 8,000 active endpoints out there. That means there is a lot of storage system, potentially your collaborators, campuses, that have already installed and are making Globus available. So you could be just leveraging them just like you would use other tools to move data, right? So I think we have a map that Ian loves. So this one is just to show you sort of distribution of endpoints. Obviously a lot in the US, but we do have endpoints in other countries. I'm just going to talk about a few examples just to give you a flavor of, okay, how are people using this, right? So I've talked about capabilities, talked about interfaces, and so on. So the first one I'll take is the University of Utah. So these guys are of the Sloan Digital Sky Survey, and he is looking to move data, and he's really looking at it as a back-end thing. So it's not that every user is moving data. So they're collecting large amounts of data, and they need to move it across to a different location. So he is using the CLI. He's scripted it, and he's moving data using that as a way to every day, sort of a very daily thing of moving data back out of from where it is collected somewhere else for processing, right? If I remember right, they're up to petabytes of data that they have moved, and it's an ongoing thing. So it just runs in the background and uses Globus to keep transferring data out of there. So it's not a one-off use, it's not an end-user use, but it's something that is being used in the project for moving data. So this is, she's at the University of Illinois, Anne Swarovski. She's at the University of Illinois, she's a meteorologist. And her use case is that she has large amounts of data that she needs to move across the various Exceed system. So Exceed is this NSF infrastructure. It provides computing, distributed computing across many centers. And wherever she has allocations, she needs to move data around so she's able to process it, right? Purely end user use case. So she has some data, she knows she needs to move it there for processing, so she triggers a transfer. If I remember right, she was up to about 5 petabytes, I think, in different, I think about 50 terabytes to different Exceed machines, right? And she's just using our web app, one-off. As she needs it, she comes there, she moves the data, and that's sort of a user pattern from an end user. This one is LIGO. It's the gravitational guys. So these guys, for them, the requirement is that if they have a finding, they need to make all of their data available, right? So literally pack rats. They need to keep all the data that they have ever collected, so that if something does happen, they have to make it available. So in their use case, it's sort of disaster recovery. They need to make sure that there's a second copy, they can always go to it. Again, Dan Kozak has sort of scripted this. It runs for them such that the data gets just moved for resilience. Every so often, as the data gets collected, it gets moved to another center using Globus, right? And then the last one I have, this one is a very interesting use case. Erin Miller is a researcher out of PNNL. She had an allocation she does often come out to Advanced Photon Source. She gets an allocation there to do some experiment. And traditionally what they do is she'll get 3 days, 4 days time at APS. She will come in and she will collect as much data as she can, write everything into a hard drive, take it with her to PNNL, analyze it, and then say, oops, I really needed something else, or I should have changed the parameter, or something like that. So this was a challenge we worked with PNNL to say, how can we support the fact that her analysis sits at PNNL, and she really needs quasi-real-time, I wouldn't say real-time, quasi-real-time viewing of it, right? With even a delay of 10, 15 minutes, so then she can change how she's collecting data to make it more useful. So what we did was we integrated Globus as a part of her application that she uses for getting the data at APS. So once she gets the data, she says, okay, I've collected sufficient data, I want to move it to Globus, move it to PNNL, and we used the Globus API to move the data there. She was able to run her analysis, do some viz, and then be able to change what she was doing with the experiment, right? So we did this before, it's probably been a year now since this happened, but there's a pretty effective use of her 3 days at APS. We were actually able to get the data out to PNNL in useful time, and for her to be able to see it and make it effective. And in this case, I don't think Erin even knows that there's globus.org as a web page, right? All she knows is her application, and she pressed a button when she was ready. It moved the data for her. She visited. She saw it. So we are happy to be sort of behind the scenes as needed, and we're outsourced. So that's one of the. We are starting to see more of the portals and the science gateways starting to use us like that, where they sort of outsource pieces to Globus. So the platform aspect of it is pretty critical. So one last thing to mention here, we are a group out of the University of Chicago, and we are operating this service. So Globus itself runs on Amazon. So it's the service that does the management itself runs on Amazon. It's a hosted service, right? So there is, so we operate a service for the research community. So the way we do this is that we have a lot of, we do get grants, and we get research grants to do new development. But for sustaining sort of operating a service, we have a freemium model. So the basic data transfer that you saw where you're moving data is free, but typically institutions subscribe to get some enhanced features, including data sharing, tools for the administrators. So if ALCF sets up an endpoint, the admin of the ALCF would like to see all the transfers that are happening, be able to block users, sort of the administrative aspect of managing the endpoint. So there's some administrative pieces there, the publication. So there are a few pieces that are sort of a part of the freemium model. So typically institutions purchase a subscription to Globus and then make that available to the end user. Right? That's the model that is used by the group for sustainability. Any questions? Anything I can clarify now? Yes.
I'm wondering what are the security issues? I could list a range of things I can think of that could go wrong with this, but in practice, has it ever occurred, for instance, that somebody shared their entire home directory and things went really, really wrong?
So typically how it works is that when an institution sets up an endpoint, the administrator determines whether they want to allow sharing or not. The administrator determines which directories they want to allow sharing. So, Lawrence Berkeley Lab has sharing enabled, but only from your project space. You can't share anything else. They can put excludes on directories. The administrator also can can set a configuration saying you can only do read-only shares, which means you can't allow anybody to write in, but you can share for people to download. They can also pick users who are allowed to share. So some institutions often will set up a Unix group and add people that they want to allow sharing to. Only those users can share. Not everybody on the endpoint can share, right? So when you install Globus on a storage system, by default, you can only do transfer, and that's integrated to your current security. The administrator chooses to enable sharing and then has all these many, many knobs to control who's allowed to share, which part of your file system you're allowed to share, what sort of sharing is allowed, and so on. So we often see read-only shares. We do see sort of sysadmins turning on something and then saying read-only shares. Read-write gets a lot more locked down because you don't want something. Read-write gets used, for example, in cases where somebody is running. We have a core center that does analysis of imaging. And their use case is that for their multi-institution study, everybody who collects data needs to write data into their location so that they can take it from there and run analysis. So this is this group that specializes in analysis out of MGH, Mass General Hospital, right? So they have an endpoint that's set up. They create a folder, and they do read-write just for that institution. So those guys move their data in. They use our API to see that a transfer happened, automatically move the data out, and do the analysis, right? So it's a little bit more restricted than saying anybody can get in, but that's sort of how share write is used. Yes?
I have a second question.
Sure.
Totally unrelated to the first one. Has anybody in this community ever thought of sending over hard disks with UPS instead of shuttling around petabytes of data?
Yes, people do move around. Yeah, I mean, APS, the Advanced Photon Source, that's par for course for them. Oftentimes.
Could Globus just do it? I click and I say,
yes.
I want this 50 terabytes of data moved by tomorrow.
Yes, that's exactly where we are going, right? If you look at any of the large acquisition systems, you also said yes, right? It's very, very common to ship disks, right? But there are lots of challenges with it. You don't know, you haven't looked at your data till you've gotten there. If your hard drive has issues and things like that, and it's slower. Interestingly, we did do some studies, SneakerNet versus moving it across a network. We call it SneakerNet. If you move data on FedEx, it's often called SneakerNet. Versus, depending on how big your pipe is, how you move data. So it is very common in this community to ship hard drives, and we are working with a lot of the groups to sort of change that. I think I'll take Advanced Photon Source as an example. They have now a public endpoint that has been set up so that when somebody collects data, they can move their data there and then have it just moved using Globus as opposed to putting it on hard drives and taking it over. So that's what we're looking to change, but that is very common these days.
What do you mean by change? If I want to send 10 terabytes of data by tomorrow across the Atlantic, it's not going to happen across the network.
Yes, 10 terabytes of data across Atlantic, probably not unless you have dedicated networks, right? So then you might have to ship. Yes. Yeah, then you have to ship, and then take the risks that come about.
But which risks? The risks are not greater. One can do checksums and then
Retransmit automatically, or you call back to APS and say, could you do that hard drive, that part of the file system again and send it to me? So it depends on your use case, right? You're taking, if the use case is, if the use case is 10 terabytes of data across Atlantic the next day, yeah, probably FedEx is your best bet. But that's one end of the spectrum. The average use case is that I'm here at APS, I have 4 or 5 days of allocation. I have my colleagues who want to see the data as I collect it sitting halfway across the world. As the data comes out, can I start moving the data to them, a copy of the data, so they can do some analysis, right? That's the more common use case. In that case, we can help, yes. In your use case of 10 terabytes.
I don't mean to start an endless argument, but I don't think that's you try to downplay the use case, but on these big machines, it takes a few hours to generate terabytes of data.
And how many of them want it moved across the Atlantic in one day? If that's the use case, great. I mean, you have to ship it. There's nothing you can do.
From West Coast to East Coast, how long does it take to move 10 terabytes?
Depending, if you're moving from NERSC to LCF, if you're looking at well-connected ESNet sites, you can move quite a bit of data. I don't have numbers at the top of my head, but you can move quite a bit of data. There is a chart somewhere I can send you where we have said if you do a good deployment of your network, which we have like tools for you to figure out and do a good deployment of, if you do a good deployment of the network, especially in the research and in enterprise here in the US, a lot of money goes into building good bandwidth. 100 gig connections are common across many of the big centers. And most universities through NSF have started setting up 100 gig centers. So you can. I don't know whether you could do 10 terabytes. I don't know. Off the top of my head, I can't tell you, yes, that's possible. But the research community, at least in this country, is blessed with very, very good bandwidth. And whether you can use it well, using the right tools. So that's kind of the goal, right?